Hi everyone, in this video I'm taking a look at the very final part of this question 7a from the 4-unit HSC exam in the year 2000. So I've already worked through part 1, 2 and 3 in prior videos, so definitely take a look at those if you haven't already. This final part 4 is kind of dependent on you understanding these prior parts. So you kind of need to have gotten your head around them before this part's going to make any sense. This final part 4 asks, does the result of part 3 hold if the natural log, ln, is replaced by log 2? And then give reasons for your answer. So let's take a look. Basically, in asking does it still hold for log 2, what it's really saying is, is this sum from I is equal to 1 to n of xi log 2 1 on xi maximized at log 2n? So that's following on from part 3 where we showed that the sum of xi log 1 on xi is maximized at log n, and that's where we're using natural logarithms, the log base e. Now we're asking, and actually it's worth pointing out that in showing that we ended up with this inequality, which kind of let us make that conclusion. Essentially, are we going to get that same inequality where instead of log n everywhere, we just put log 2? And hopefully, when you kind of frame it in that way, instead of log n, we have log 2. Hopefully what jumps out at you is the change of base rule with logarithms. So something you probably would have learned a long time ago, probably when you first started learning logs, because maybe when you first started learning logarithms, you learned base 10. At least that's what I remember learning. And then we learned the change of base rule and how to change from log 10 to other bases. And only quite a bit later did everything suddenly become the natural logarithm, and that was the default. So hopefully change of base is something you've kind of learned so long ago that, and you've used it so often that you're very familiar with it. You don't want it to be a kind of rusty, distant memory, because the thing with 4-unit is they can throw this stuff at you, these kind of things that, you know, maybe you learned for the first time many years ago, but you have to have it all handy. I think that's one of the hard things about 4-unit. But essentially, this change of base rule that we need to make use of here, it basically says, in generic terms, if I have a log of base b of a, so the log base b of a, if I want to change that to some other base, I'm just going to call it log x, say. Well, that's going to be log x of a on log x of b. And then making use of the change of base rule is all about making sure you pick the right x, a, and b for what you're dealing with. So, in essence, what we can say is, therefore, if we're concerned with log 2 of 1 on xi here in this summation, we can say the log 2 of 1 on xi, that's basically going to be the natural log. I'll just write it as log e to make it really clear here what we're dealing with when we're changing our base. So it's the log e of, in this case, a, which is 1 on xi, over the log e of our original base, which is, in this case, 2. So the log 2 of 1 on xi will be log e of 1 on xi on log e of 2. And again, now that I've made it really clear, we can just write it the way you're probably used to, which is just the natural logarithm of 1 on xi over the natural log of 2. Alright, so now if we want to expand on this to get our full summation, we can say therefore the sum from I is equal to 1 to n of xi log 2 1 on xi. What's that going to be equal to? Well, we can just now sub this in here. So that's going to be the sum from I is equal to 1 to n of xi natural log 1 on xi over natural log of 2. Just a straight substitution. This log of 2 has nothing to do with I, so I can bring it out. So that's going to be 1 on the log of 2 times the sum from I is equal to 1 to n of xi natural log 1 on xi. And now we can make use of our inequality. So in part 3, we showed that this here, which is what we're dealing with, is maximized at log n, or in other words, less than or equal to log n, so, or natural log of n. So now we can take this equals and make it an inequality, 1 on natural log of 2, times the natural log of n. So in inserting natural log of n for this, that's how we get our inequality. That's why part 3 was useful. That's kind of where we're being led. And now we're basically back in change of base, but we're going the other way. So we've kind of got this log n on log 2. So if we've got, again, if I write it out, just to be really clear, we've got log e of n over log e of 2. And if we want to get from this to this, so we're going now from the right-hand side back to the left-hand side, we can write that as, well, what's down here, 2, so that can become the base, log 2, and what's up here, a, that becomes this, so it's n.
Sonic boom!
So now we can say that this sum from I is equal to 1 to n of xi log 2, 1 on xi, is less than or equal to log 2n. So it is basically replacing, in part 3, wherever we had log n, or sorry, natural log, ln, log of e, we can actually replace it with log of 2 and the inequality still holds. So we can make that conclusion. Therefore, the result in part 3 still holds for log 2. And I think this here is more than enough as reasons. The question says give reasons for your answer. You know, some students might just take a punt and say yes it does or no it doesn't, but I don't think you're going to get any marks for just a lucky punt. You're going to have to at least show some kind of rationale, and I'm pretty sure the question writers wanted us to almost hark back to our basics of logarithms and hear the change of base rules. So again, it's not a huge amount of work to prove this. It's just having the depth of, I guess, your knowledge pool here. And, you know, have you just crammed in just the new stuff from 4 unit, getting ready for this exam? Or have you, over the many years of high school, really solidified your knowledge and been building on everything you've learned from year 7, 8, 9, 10, 11, 12. And I guess this is the kind of question that will separate those kind of students, the type who just cram stuff in and then forget it right after the exam, versus those who are building a really deep, solid knowledge of the math. And yeah, I think it's quite a nice question when you think about it from that perspective. So yeah, hopefully that explanation all made sense and you found that helpful. And that's it for question 7a. So tick boom.